Okay, so this video is focused on the two advanced trig identities, and the previous video it did have the advanced identity, the sum and the difference and the double angles, but it was more as in proving and solving equations. Okay, so but these are a different set of problems. It's going to just be focused on just using the formulas. Okay, once again, I'm going to give you the entire unit circle completely filled out because I'm not testing you on this time. I tested you guys on that last time. And then the sum and difference formulas, and also the double angle formulas. And so basically you just have to apply them. Okay, so I kind of separated it out. You can see some of the stuff from part 2, and then it goes down here from part 1 based on the lessons that I taught. Okay, so the sum and difference formulas. Let's see. So in part 2, these are very these particular problems are very what is it? What's the word I'm looking for? Very representative of the problems that we did for the lesson. Okay, and so these are potentially something that you really have to know. Okay, so these are pretty basic. I think the other video had the more difficult problems in it. I am going to do just one of this, okay, because I don't think you need that much practice on this if you just know the formulas. Okay, I'm gonna do, well, let's just recap in the 5 pi over 12, and I can give you a choice. You can use sum or difference. Most of the times you guys are going to use sum. 3 pi over 12, this could be taken, and then 2 pi over 12. So that could be cosine of pi over 4 plus pi over 6. And then you can go ahead and use the formula, and that'll be, oh, let's just, why not, cosine of pi over 4 times cosine of pi over 6 minus sine of pi over 4 and sine of pi over 6. And so using the unit circle, that is going to give you the square root of 2 over 2, cosine of pi 6, square root of 3 over 2, minus square root of 2 over 2. Sine is 1/2, and that's going to be square root of 6 over 2 minus square root of 2 over 2. So that's going to be square root of 6 minus square root of 2 over 2. Okay, so cosine of pi over 4 plus pi over 6 is going to equal this. Okay, my laptop is still very hot. Okay, let's do this one, tangents, because I don't think I had that many examples with tangent. Equals, that could be separated as 4 pi over 12 plus 3 pi over 12, and tangent of 4 pi over 12 is pi over 3 plus pi over 4. We know all of that. And then I can use the formula tangent of pi over 3 minus or plus tangent of pi over 4 over 1 minus, and then those two multiplied with each other. So that is going to give you tangent of 3 plus 1 over 1 minus the square root of 3 and then square root of 1. So that is going to be square root of 3 plus 1. and 1 minus the square root of 3. We have to rationalize the denominator. So we have to use the conjugate. So that is going to be square root of 3, the numerator, and plus 3 plus 1 plus square root of 3 over 1 minus 3. So that is going to be 2 to the square root of 3 plus 4. Let's go ahead and rewrite it in the correct way. We always write the real or the rational. 2 to the square root of 3. Square root of 3 over negative 2. And then that you can even further simplify that. Okay, I don't think I did it. Oh, no, I did. Divide negative 2 minus the square root of 3. Okay. And the tangent of pi over 3 plus pi over 4. This is so messy. Equals. Okay, so you look at a problem like number 10, and it just tells you to simplify that. Why is this in this? Oh, yeah, this is okay. I just need to simplify that. This is pretty straightforward. You're going to just use the formulas: sine of x, cosine of y, plus cosine of x, sine of y. And the number one thing is that you distribute that negative sign. Okay, and then sine of x and cosine of y minus cosine of x and sine of y. Okay, then oh, sorry. Okay, and then distribute x cosine of y plus cosine of x sine of y minus sine of x cosine of y plus cosine of x sine of y. And you see that those two are going to cancel out. So you just end up having 2 cosine of x sine of y. Okay, it's a fairly easy simplification problem. Okay, so we had several of these problems. Okay, something like this, and you need to be able to do it. Okay, so it gives you what A is, what angle B ratio is. So based on that, we have to find it. So let's see, cosine of A is negative 3 over 5, which tells us that that's the x and the radius. It also tells us that it is between pi halves and pi, so which tells us it's in quadrant 2. Okay, so it's in quadrant 2, so the way that it's going to look is kind of like this. And so the x is negative 3 and the radius is 5, and it's a 4, 3, 5, and the y is going to be positive. So I know some of you guys just figure it out, okay, but the sign is going to be different. The sign of your remaining x or y, r is always positive, is going to be different if you don't determine what quadrant it's in. You do not need to draw this picture. And if you can figure it out without drawing the picture, fine, but you have to know the sign. Which means Ms. Alstrom is going to maybe possibly put something that is not, and some of you guys are like 3, 4, 5. I'm just going to use a 4. This time the sign of A is actually positive, but you might not get that lucky. Okay, so I'm going to write down what I found. Sine of A, because it tells you to find cosine. To find cosine of the difference, you need both sine and cosine of that angle. So that's going to be 4/5. Okay, the other angle, let's go ahead and just put these as different colors so I have it. The other angle is, oh, don't like that, is cosine of B, which is -4/7, which is x over r. Now that is in this quadrant right here, so that is in quadrant 3. So it's going to look like this. It's going to be, so it's going to be a -4. The radius is 7. And we need to know the y value. And the y value is going to be 49 minus 16. 49 minus 16, I believe it is square root of 33. So this is going to be negative square root of 33. So this is in quadrant 2, right? So I'm just going to check that really quick. Okay, so 49 minus 16. And so what I've decided for the calculators is I ordered some 4-function calculators in Amazon. It's actually coming today. And so I'll be distributing those and just passing it around if you need to use it for multiplication or division. Okay, so for this, it's sine of B equals negative square root of 33/7. So now that I have both of my sines and cosines, if they ask for tangent instead of cosine, then you have to find the tangents. Okay, so let's go ahead and set it up. So cosine of A minus B, and I'm not going to make it confusing, so I swap things around. Okay, whoops, where am I? Okay, A minus B, and that is going to be cosine of A and cosine of B plus sine of A and sine of B. We're a little down in our house today because our dog Leo is at my brother's house for the next 2 months that my mom's going to be going to go to Korea. So we don't have a dog around, which is a sad thing. Okay, so we have a -3/5. So I'm going to be kind of down at school too because, you know, Leo was he knew how to heal me. I mean, I still have Kiki, my cat, but she's old. She just sleeps a lot. A minus B equals, that is going to be a 12/35. That's going to be -4 to the square root of 33/35. See, these kind of problems that ends up becoming both of the dimensions of the triangles are not a perfect Pythagorean triple. You end up having easier answers to solve in the end, because then you don't have to multiply a whole bunch of numbers, because one of them ends up becoming a radical. 4 to the square root of 33 and then 35. Okay, that's it. Sine of V over U, I think you guys should be able to do that on your own. I mean, the key is there. I just put it there. Maybe I'll just quickly just do it. It's just telling you to expand it out. Oh, no. It had some stuff on top, like what U was and what V was. And it's the same property. I don't think I'm going to do that. Okay, next. We had these set of problems that were all sum and difference. Okay. Number 66 is pretty straightforward. You just have to find out, the x value, and then you have to find the cosine, okay? And then you can find the tangents using that. And then it gives you the y over x, and then it tells you what quadrant it's in. And so that's pretty straightforward, okay? Number 66, 67, 68 is pretty straightforward. Now, number 69, 70, and 71 are the ones that I want to really focus on, okay? And some of the 8A kids were already doing those, and we were kind of doing them together. And at first I was like, oh, it's not going to be on the test. And then I looked at it and I actually did it, and I realized, wow, these are actually very good problems, and I might have something like it where you figure it out on the test. So number 69, it says, write square root of 3 sine of theta plus cosine of theta in the form k sine theta plus a, where k is greater than 0 and a is between 0 and 2 pi. So we know that it's in quadrant 1, 2, 3, 4. It's not going to go past the full revolution. Okay, it's not even going to include 0, and it's not even going to include 2 pi. Okay, so how do you solve this? Well, first, it gives you this right here. It gives you the formula for sine, the sum of sine. Okay, so if I take that, and if I just take theta plus a, and if I expand that out, it becomes sine of theta cosine of a plus cosine of theta and sine of a. But it's being multiplied by a k. So what I need to do is multiply this entire thing by a k also. So that becomes k times sine of theta cosine of a plus k times cosine of theta sine of a. Okay, I just distributed the k over. And then it gives you this right here, and say, write that in terms of this. Okay, so if you look at the two terms, and I'm going to put it right underneath it, sine of theta plus cosine of theta. You notice that it has some similarities. It has a sine of theta and a sine of theta, and a cosine of theta and cosine of theta, which tells us that this term is going to equal this term, and this term is going to equal that term. But something got simplified in the way, okay? And so, first, we need to find what A is, okay? And we need to find what K is to fill this in. We need to find K, and we need to find A. Theta stays theta. Okay, so when I see that, there's two ways to solve this too. So you can put K times sine of theta cosine of A equals square root of 3 and sine of theta. I'm going to say that first term equals the first term. And that means that the second term equals the second term. Okay, and so what I notice is that I can divide both sides by sine of theta, and I get k times cosine of a equals square root of 3. If I divide both sides by k, I get cosine of a equals square root of 3 over k. So I'm trying to look for k. Over here, I can multiply theta, and k is cosine of theta. And so that's going to give me a sine of a equals, that's 1 over k. Okay. Now, k's have to be equal to each other. If you look at remember the unit circle, the possibilities that sine and cosine could be, it could be some something between a 0 and a 1. Okay, or it could be interchangeable, and it could be plus or minus. And then it could be square root of 3 over 2, plus or minus, and plus or minus 1/2. And those could be interchangeable. And then you can have a square root of 2 plus or minus square root of 2, plus or minus square root of 2 over 2. And the cosines and sines could be interchanged, which would be the same thing. If you look, the only thing that has a square root of 3 and a 1 is with a denominator of 2. So I can deduce that k equals 2. And once I put those in, cosine of a equals square root of 3 over 2, and sine of a equals 1/2, then it gives me my terminal point, square root of over, and then 1/2, what my x and y's are. So when cosine of a, or x, is square root of 3 over 2, and sine of a is square of 1/2, the only option for this number to be is that a equals pi 6. Okay, so I found the two things that I need to find, k equals 2, a equals pi over 6. So in this form, I could write that it's 2 times, I don't need a parentheses right there, sine of theta plus pi over 6. And I can actually expand it out and check. Okay, another way of solving this is to find tangent. So tangent of a, using these two, is going to be 1 over k over square root of 3 over k. So tangent of a equals 1 over square root of 3. So that means that's going to be my, or square root of 3 over, is it 3? Yeah, square root of 3 over 3. So that tells me that that is going to be, let's see, so a could be pi 6, or where tangent is positive, it could also be, what's the angle, also what's the other angle that it could be? Pi 6 and square root of 3 over pi 6 and 7 pi over 6. Okay, but in that case, if it was 7 pi over 6, that's in quadrant 3, and that means my cosine and sine would both be negatives. But they're not, they're positives. Okay, so I can say that a is pi over 6, and then I know what k is because the terminal point is once again square root of 3 over 2 and 1/2. So therefore I know that k equals 2. Okay? Next, let's do number 70. 70 tells us to first find k times sine of theta plus a. So I need to find k and I need to find a. I need to fill those in. And that equals 2 cosine of theta plus 2 sine of theta. Okay, but when I expand this out, it's going to be k times sine of theta cosine of a plus k times cosine of theta and sine of a. Okay, so if I compare the left-hand side and the right-hand side, I notice that we have a cosine of theta here and a cosine of theta. And we have a sine of theta and a sine of theta. So in order for these to match up, I am going to rewrite this using the commutative property like this, so that they match up. So we have k sine of theta times cosine A plus k cosine theta sine of A. Now they match up. We have a sine of theta for this first term and that first term, and we have a cosine of theta for the second term. So I can set this one and this one equal to each other. And this one equal to each other. So we have k sine of theta cosine of A equals 2 sine of theta. So I have cosine of A equals, that's going to be 2 over k. And then I have a k cosine theta sine of A equals 2 cosine theta. And then I end up having a sine of A equals 2 over k. Okay, now we have to figure out what k is. I mean, this is not as easy as the other one. Okay, once again, possible points that we could have gotten is 0, 1. But then I can use tangent. I can use what tangent is. Tangent of A is going to be sine of A over cosine of A. And if I do that, it becomes 2 over k and 2 over k. So tangent of A has to be 1. So where is that A? Where are the A's? What could the possible A's be? Well, if it needs to be positive 1, then it could be at angle pi over 4, or it could be at 5 pi over 4. But at pi over 4, both cosine and sine are positive. But at 5 pi over 4, both cosine and sine are negative. So it excludes that. So I know A equals pi over 4. So the terminal points for that is square root of 2 over 2, square root of 2 over 2. So I know that this one is going to equal sine of A, and that's going to be cosine of A. So, like I said, sine of A equals 2 over k equals square root of 2 over 2. So I can solve square root of 2 over k times k equals 4 by 2. K equals, is it 4 to the square root of 2 over 2, and k equals 2 to the square root of 2. Same thing for cosine A. Cosine of A is 2 over k equals square root of 2 over 2. So that's 4 equals k times the square root of 2, root 2, square root of 2. So k equals also 2 to the square root of 2. They have to be the same. Okay, so once I rewrite it, you can rewrite it as, they want it in 2 to the square root of 2 times, I keep on putting a parentheses there, sine of theta plus pi over 4. Okay? Now, 71. 71 is the hardest out of them all. So we had k cosine of theta plus A, and this equaled 2 cosine of theta minus 5 sine of theta. Oh, my computer's getting so super hot.
It's not even funny. Okay. Okay. So once again, I'm going to use K cosine of theta cosine of A minus sine of, oh, I forgot the K. I forgot to distribute the K. K sine of theta sine of A. 2 cosine of theta minus 5 sine of theta. Okay. Let's see. So we have a cosine of theta and a cosine of theta and sine of theta. Sine of theta, first term goes with first term. So K cosine of theta cosine of A equals 2 cosine of theta. And then we have a negative K sine of theta sine of A equals negative 5 sine of theta. Okay. And you have to take the negative sign. So this is actually plus, and then that entire thing is negative K. That's plus and negative theta. There's no such thing as subtraction. It's actually adding negative integers. Okay, which is something that, you know, there's no such thing as multiplication. I mean, division. There is just multiplying the reciprocals. Okay, so going back to this, and I do a K times cosine of theta. K and cosine of theta. So cosine of A equals 2 over K. Oh, I'm doing the same one over there. Oh no. I'm not doing the same. Okay. And then divide by negative, whoops, negative K sine of theta, negative K sine of theta. So we end up with sine of A equaling 5 over K. Okay, the problem is that nothing like this exists in the 16 terminal points that we studied. So this can belong inside because K could be anything and A could be anything. So the way we find this is we have to find the tangent of A. Tangent of A is going to be sine of A over cosine of A. So that's 5 over K over 2 over K, which is 5 halves. So tangent of A equals 5 halves. There is nothing that we learned. Okay, but that actually exists in the unit circle because tangents are infinite. They're slopes. So within all of the 16 angles that we learned and the terminal points that go with it, there is a tangent that is going to be 5 halves. Once again, we didn't learn arctangents, which are the inverse tangents, where in order to find A, we take the inverse and write it like that. Okay, or you can say A equals arc tangent of 5 over 2. So you can just represent that in that way. And on the test, there's not going to be a problem where you don't know the terminal points, the cosine and the sines. It's going to always involve, but just so that you know the answer to this. Okay, and then if we do our, we know that arctangent, this is going to be 1.5 halves is like, what is 5 divided by? 5 divided by 2, which is around 2.5. Okay. It's a positive angle. Positive slope. So we know that I came back with a calculator. Okay, so if I do the inverse, 5 divided by 2, and I put my mode in degree. It's between 90 degrees and since both the cosine and sine is positive, it's between 90 degrees and 68.2 degrees. So it's going to be closer to pi halves than pi. Well, it's going to be greater than. It's going to be between pi halves or pi thirds and pi halves. Okay, so it's going to be in quadrant 1. Okay, so I could draw my little Pythagorean theorem, and I could draw my y as 5 and my x is 2. And so that's 25 plus 4. 25 plus 4. Right? 25 plus 4. So that's square root of 29. Okay. So I know that my cosine is going to be the k value is square root of 29. This is going to be cosine is 2 to the square root of 29, and sine is going to a is going to be 5 and square root of 29. Okay, so my k value is going to be square root 29. So my a value is going to be this entire thing, or this entire thing. I could rewrite it in both ways. And so it's going to be 29 times cosine of theta plus arc tangent of 5 over 2. Once again, it's not going to be on the test, okay? But if you wanted to know it, then there it is. Okay, let's see. Basically, part 1 through 8 involved pretty much the kind of problems that I did for number 11. Okay, but we can do them again. Let's see which one I'm gonna do. Let's go ahead and do number 3 because that one involves a tangent. Okay. And so the tangent of 2 theta, using the formula, you can say it's tangent, I use a sum, and then basically 2 tangent theta over, and that's a double angle, okay, double angle formula. And we know that tangent of theta equals, negative has to go on something, we don't know. So let's figure it out. I'm not going to write it yet. It's in quadrant 4. So in quadrant 4, all students take calculus. So in quadrant 4, cosine is going to be positive, sine is going to be, x is going to be positive, y is going to be negative. So it's that negative 5 over 12. So y equals, oh no, it wants you to find cosine. I'm sorry. Okay, so cosine of 2 theta, doing number 3, okay, is 1 minus sine square theta. Or you could have used, 2 sine square theta. And you could have used 2 cosine square theta minus 1 if you wanted to. And so my y value is negative 5. My x value is 12. in quadrant 4, like this, that, and so my -5, +12, and that's a 13 right here. The radius is going to be 13. And so therefore, my sine of theta is going to be y, which is -5 over 13. And the cosine of 2 theta equals 1 minus 2 times -5 over 13 squared. So 1 minus 2 is 25. Gosh darn it. 25 over 169 equals 1 minus 50 over 169. As 169 minus 50 over 169. So cosine of 2 theta equals 169, which is 119 over 169. Okay. Pretty much number 4, you do it the same way, except it gives you y over r. We know that it's going to be in quadrant 4. Okay. Part 2. In part 2, there's some interesting problems that I just want to point out what it involves using the formula. Okay. Acute angles. Remember, acute angles is always in quadrant 1. And it tells us to find, using this tangent of A, is y over r, so that's 7 over 24. So quadrant 1 is 24, and 7 is a 25. So tangent of 2A equals 2 tangent of A, 1 minus tangent squared A. It already gives you the tangent, so you can straight use it. 24 over 1 minus 7 over 24 squared. So that's going to be, what is that? 14 over 24 divided by, I already know that my numerator is going to be 24 because that's going to be the common denominator. And that's going to be 24 minus 49 in my denominator. No. 24 squared. That's going to be 24 squared. Okay. And so that is 14 over 24. It's not divided by, this is already multiplied. I'm trying to do this really quick because, you know. Oh, that's interesting. I see that I have a mistake on my key. 576 over 527. I think that's a typo on my key too. 14. Oh no, I reduced this. Okay. 7 over, that's 12 times 576 over 527. So you get tangent of 2A equals 336 over 527. And basically, you're just putting into a formula. Okay, I'm not going to go ahead and find cosine of 2A. You can check it on the key. Obtuse angles. Obtuse angles are, acute angles are between, so acute angles are between 0 and 90 degrees. So it's going to be always in quadrant 1. Obtuse angles are between 90 and 180. So those are always going to be in quadrant 2. So this is going to be in quadrant 2, guys. Okay? And it gives you the cotangent. The cotangent of A equals negative 12 over 5, which means x over r. Okay? And if it's in quadrant 2, okay, that's going to be negative 12. The x is going to be negative. Radius is 5. And then, no, not the radius. This is going to be y. Sorry, I'm getting tired. Y, and the radius is 13. So I need to find the sine of A, because I need to do cosine of 2A. So I need to find sine of A. Sine of A is going to be y, 5 over 13. Cosine of A is going to be negative 12 over 13. So cosine of 2A is going to be cosine of, I'm going to use cosine squared. 2 cosine squared minus 1. 2 negative 12 over 13 squared minus 1. So 2 times 144 over 169 minus 1 equals 2 times. So I get 119 over 169 cosine of 2A. I don't see that these problems could be particularly hard. Okay, but some kids were having trouble with this, and it's just understanding the formula. Okay, the formula for sine of 2x is 2 sine of A and cosine of A. Okay, could have used any kind of variable. And it's understanding that, yes, there is going to be a number multiplied it in front, and these b's, there's going to be a number in front of the x. Okay, so if I take this, and you see this same layout, sine and cosine, and it's the same angle. Okay, but the 10 is different. You need to make it 2. You have to factor out the 2. So this is 5 times 2. And this entire thing right here now fits into that formula. And so when I condense it, you're going to have this 5 outside. The computer doesn't want me to write anymore. It has the 5 outside. The computer doesn't want me to write anymore. It's stuck. Oh my gosh, this is not fun. Ugh. I don't know. It won't let me. So this 5 is not part of that formula, but this entire thing is. So I'm going to take the 5 out and multiply it with the condensed form, which is sine 2, and this entire thing is A. Okay, 17x. 5 sine, and it's 32 times, I can't do math right now. 17 times 2, 34. Okay, so now you can see what A is. A equals 5 and B equals 34. Okay. So for this one, I'm going to factor out a 2, and I get 113. So sine of 8x, the angles are the same. So I can use this part and use that double identity 13 times sine of 2a, this entire thing is a, 2 times 8x, so 13 sine of, you see that ripple? 16x. So a equals 13 and b equals 16. Okay. Part 3 has some more of these problems. The double angle using the formula. But once again, the first video is, I feel, where the harder problems are going to come from. Okay. Using the identities to verify or to solve equations. Okay, that was the wrap-up video. Yeah, good job, guys.